how to write the equations when you have different solutions or solids being mixed with another solution. So in this first problem, we have a complex ion being mixed with a solution. So we will just have a double replacement because they're already in aqueous form, and this cannot dissociate anymore into, well, this can, but the K is pretty big. And if it does dissociate, it just means we're going to have Ag plus and H2O reacting. So there are two ways you can write it, but one way is to make sure when you write it out, it's a net, so sodium's not going to participate in this reaction. So when you plus this with this, you are going to have a double replacement. So Ag will react with H2O3, and this will give us another complex ion, as in the data table says. And if you want, you can add water here, if you want. Now the next one is really similar as well. This will dissociate because it's already aqueous, so it's basically just going to be Ag plus and NO3 minus. So what can happen is double replacement. We're going to have this. I'll make sure to balance what you need to balance. Ag as 2O3, 2 minus 2, and then 3 minus, plus just the nitrate ion solution. Okay. But the next problem, the difference between these two separated by the dash, is that the bottom here are solids. So solids, you cannot just dissociate it and then double replacement it. You have to consider the fact that solids will not completely dissociate into their aqueous forms. So this is already aqueous, right? So there are already nitrate ions and silver ions, but these have limited solubility. So we need to take into consideration of their K solubility. We'll go with this first problem. So AgCl first has to dissociate into Ag plus and Cl minus, and this is balanced. And this solubility constant is a limited number, and the number for that is 1.8 times 10 to the negative 10. And then when it limited dissociates, one of these will react with the ammonia to form a something. So you want to check data table for that something, and the data table says it's going to be a complex ion which has a large K, and yep. So then the K formation of this complex ion, according to the data sheet, is this. And then you have to combine both of these equations to get the net equation, which is going to be, canceling out these, make sure everything is balanced. So the AgCl solid is going to plus the ammonia in the solution of ammonia is going to give some chloride ions and the complex. Make sure everything is balanced. Yep. So the difference between these two, although you're still mixing a whole bunch of fancy stuff together that have nothing in common, the difference is that if it's already aqueous, you can just use double replacement. If it's solid, you have to consider the KSP and then combine their Ks. So that means this new equation's K formation is going to be the KSP times the KF. So I made this emphasis because you see how they're mixing things with nothing in common. So it would just be double replacement. Unless it's a solid, you have to combine their Ks. Whereas in some easier questions, you just have a common ion situation. Like let's say you have some solid here and you want to put it into the solution, right? But I don't actually remember which one is a solid. But the big deal is you just write out their aqueous forms, and then because it's a common ion solution, you would just have a solid as excess, and the aqueous form, you will just, for the ice table, just put their aqueous forms concentration down here. So nothing fancy, easy stuff, you should probably know that. But the next problem is precipitate. So you're also mixing stuff, but now they're asking you what is a precipitate. So what's the difference between these two reactions? The difference is you want to find what can form as a solid. So you notice how this is still an aqueous, but we want to know what is a solid. So you would, for these precipitate problems, separate it into their ion forms, and then find out based on solubility, is based on solubility rules, what can form to form a precipitate. So what can combine to form a precipitate? So chlorine, okay, hang on. So nitrate is always soluble, so is sodium. So that means it leaves us with a possible precipitate of Pb2 plus and chlorine. So this will be our precipitate. And having that, our equation is going to look like the solubility of that precipitate, Pb2 plus Aq plus C plus 2 Cl minus Aq. So these are your precipitate problem equations. The problem will usually ask about, will there be a formation of a precipitate? So that's your Q. As for these, we know that chlorine is always soluble, so that won't form anything. That leaves us with a possible precipitate of this. And then just write out its aqueous form, making sure to balance things out.